Hello everyone, this is Karan and I welcome you again in Ora Techs. So in this episode we are going to learn that if I get any value, so that value if I want to multiply with some value which is power of 2, like 2 is power of 2, 4 is power of 2, 4 is 8 is power of 2. If such multiplications we have to do, so without using arithmetic operator, how we can do that? Okay, so first of all, let's save this project. um, Multiplication with power of 2, and it is a .c project. Save it. Okay, so if suppose there is some value, the 64 value is given over here. Okay, and so here I will take some variable to store the multiplied value. Okay, and I will give them name like this. So this will hold the value which is multiplication of 2 of a. Okay, this will hold value which have the multiplication of 4. This will hold value which is multiplication of 8. This will hold the value which is multiplication of 16. So suppose, so we all know these are power of 2, right? Power of 2. And if suppose I want to multiply it by 64, so what you will do, simply you will do like this, a, and you will do this multiplication operator, and you will this, and you will get easily what you want in ax2, right? So this is a very simple logic, you have, you know already, but I'm not talking about this. What I am talking about this is this operator, the left shift operator. Okay, so if you will left shift it by 1 bit, so you will get it multiplied that value by 2. So, and why we will use that is what is the benefit. So benefit is, if you are not using the arithmetic operators, so you are not using the arithmetic logic unit. Okay, so arithmetic logic unit, which is ALU, which is a different unit. So whenever you do such commands, your processors go to the ALU, and from ALU it does the computation, and it comes back with some result, and it shows you the result. So it takes some time, and it takes some machine cycles to run. Okay, so if you want to save that time, so this is a logic you can use to save your time, save your machine learning. So this is the optimization you can do in your embedded program. Okay, so let's quickly print this and check if it works as expected or not. So what is a here? Okay, %d. I will use x sign for the multiplication, and I will use 2 here, and I will use like this, is equals to, and %d. Okay, so what I'm going to print here is like multiplication of a. Okay, so here I'm going to print a, and here I'm going to print the ax2. That means multiplication of 2. Okay, so let's see if it works as expected or not. I saved it, I'm running it, and see, it is saying 64 into 2 is 128. It works as expected. Okay, so this is a very big value, and we will do for all value also. I will reduce this value to 5, and I will develop the logic for others also. So this is the logic for the multiply by 4, this is for logic for the 8, this is logic for the 16, and simply we will increase this, and let's do printing. So here it will change to 4, it will 8, and here it will be 16. And if I will save and run this, so see, 5 into 2 is 10, 5 into, oh, here also I should Yeah, so I should change for the better understanding. Now, now it will look perfect. So 5 into 2 is 10, 5 into 4 is 20, 5 into 8 is 40, 5 into 16 is 80. So see, this is how you can save your time by avoiding using the arithmetic operator and just using the left shift operations for the bit. This is how you can manipulate the bit and you can get what you want to do as quick as possible. So this is very important in the field of embedded to save the machine cycle, save the timing of the operation. So I hope you got something from this video, and if you learned something, then please subscribe to my channel and share this with your friends if they want to learn embedded. And you have any comments, you have any questions, just please comment down below. I would like to reply on them. And thank you for watching. See you in the next lecture. Bye.